Okay, here we are, Chapter 2. We'll just do the second part of the review, go over a few problems here from the review sheet. The first one, they want us to use elimination, and remember the goal of elimination is to find equal but opposite signs. Let's see if I can write. Here we go. And we're going to do that on either the variable x or y. It's your choice. We have to solve for both of them. So you're first going to try to eliminate x or y. So look at the quantities. Well, x is 2 and x is 3. The coefficient, right? Right here. And for the y's, y is equal to 2 and y is equal to 3 in the second equation right here, right? So it's strictly up to you which letter you want to pick on first, or which coefficient you want to adjust. Let's get rid of the x's, okay? So if we get rid of the x's, what's the common multiple between 2 and 3? Well, it looks like we could turn both of those equations into a quantity of 6x, but we want one to be positive and one to be negative. So let's multiply the first equation by a positive 3. We'll do that one in blue, and then we'll multiply the bottom one by negative 2. And then we'll see that the x's are equal but opposite signs. So in blue we'll do the first one. So we're going to distribute 3 to each and every term in there. So we have 3 times 2x, we have 6x plus 6y is equal to 24. And then in red we're going to do a negative 2. So we have negative 6x, negative 6y equals a negative 24. Well, this is a special case here because look what happens when we add these two equations together. We get 0 plus or minus 0 equals 0. Everything is equal and opposite in both of these equations, so you end up with the term 0 equals 0, which is a true statement, by the way. So that means that we have infinite many solutions. Now, geometrically, what does this mean? Or graphically, what does this mean? That means that we have the same line graphed twice, right? If we were to solve this by graphing, we would find an equation, we'd graph the line, we'd find the equation for the second, and it would be the exact same quantities for your slope and the same quantities for your y-intercept. So it's infinite many solutions. Okay, let's do number 20. And this one, hey, looks like the same type of thing, right? We have 2x and a 3x. So we could pick on the same variable x again in this problem. And we're going to do the same, multiply the top one by a positive 3 and multiply the bottom one by negative 2. And let's see what we get here. Give myself a little bit more space. So this would be 6x minus 15y equals 6. That's just me distributing 3 different times. And then in red we'd have a negative 6x. Negative times negative 7 would be 14. And then we have negative 2. And then if we add these two quantities together, the result would be 0. And then a negative 15 plus 14 would be a negative y. And 6 plus a negative 2 is a quantity of 4. So remember, we're not finished here. We have negative y equals 4, which means a positive y equals negative 4. And then we're going to take and plug this in to either one of these two equations, the quantity negative 4 for y. So let's do it to the first one. It's a little smaller. We have 2x minus 5 times negative 4 is equal to 2. We have 2x negative times negative is a positive 20, and that equals 2. Subtract 20. 2 take away 20 is going to give me a negative 18. And we have 2x is equal to negative 18. Divide both sides by 2, and we get x equals negative 9. So now we know our solution set is negative 9 and negative 4 for y. Okay. Well, let's do number 21 because it says to specifically use substitution on these problems. Well, substitution, you want to look at both equations and you want to find the variable that has a coefficient of 1, and it looks like that in both of these we have a coefficient of 1 for both y's in the first and second equation. So I think I'll use the first equation, and I'm going to solve for this y right here. So how would you do that? You would subtract 4x, and you would get y equals negative 4x minus 7. So now, every time you see the letter y, you're going to substitute this entire quantity into it, into the second equation. So let's just rewrite this second equation. We have 3x minus, there's my y, so I'm going to put a big parentheses there, and it equals 0. So that into where it used to be y, I'm going to plug in that negative 4x minus 7. Okay, this looks pretty simple, but some people tend to make a mistake right here because they think that there's nothing to distribute, when in fact there's really the quantity negative 1 there because of that minus sign. So negative distributed to a negative, of course, is going to give me a positive. So we have 3x plus 4x, and then negative times negative 7 is a positive 7. So adding the like terms, of course we have 3x and 4x, 7x plus 7 equals 0. If we subtract 7, let's get rid of that so we don't get confused. We have 7x equals a negative 7. Divide both sides by 7, and you get x equals negative 1. And then let's go back to this equation right here. We already solved this one for y, right? And now that we know what x is equal to, we can simply plug in. So we know that y equals negative 4 times x, and x is negative 1. Take away 7. We have y equals negative times negative here is positive 4. 4 minus 7. And y equals negative 3. And we're going to put that in our solution and we'll be done. Okay, hopefully this helps you with the substitution and elimination, and good luck on the test.